This is geometry. This is Unit 5. We're working on finding the angle measures in a polygon. These are all going to be regular polygons. Now what's cool about a regular polygon? It is a polygon that has all sides and all angles congruent. So what that might look like here, if we zoom in here a little bit, what that might look like is a triangle that is 60, 60, and 60. We also know that the sides are all going to be the same, like maybe 4. We could consider that to be a quadrilateral, which would have all the same angles and all the same sides. We would call that a square. That would be a regular polygon, and this would be a regular polygon. We call that an equilateral triangle, equal angular triangle. This one we call a square. It's a rectangle, but it also has equal sides like a rhombus, so we call that a square. Okay, and we can continue on the same idea with a pentagon, where all the interior angles are exactly the same, making all the sides. It would be a requirement, not making it, they don't make it, but if the sides are all the same and the angles are all the same, that would be a regular pentagon. Alright, so that's what a regular polygon is. Interior angles and exterior angles. Okay, taking a look at a picture here. If we look at a triangle, here we have the interior angle. If you extend the sides, you get the exterior angle. Together, those two angles are making up 180. We also call that a linear pair. Form a linear pair. So for us to figure out what the sum of each interior angle is going to be of a regular polygon, we need to take the sum of all the angles, and we've learned that to be n minus 2 times 180. And if all the angles are the same, all the angles, the number of angles is the same as the number of sides, so n would be sufficient. N minus 2 times 180 divided by n would actually give you each interior angle if they were all exactly the same. Each exterior angle, the exterior angle, we know that the total sum is 360. We don't need a formula. It is always the exact same thing. It's always 360. So if we divide that by the number of angles, that's going to be the sum of not the sum, but that is each exterior angle of a regular polygon. So let's go try this. Each interior angle of a regular hexagon is 120. So if we draw this regular hexagon, I'll give it a try. I don't know how it's going to go. Not too bad. Probably slanted a little bit. These angles look a little small. They're saying that it's 120. Each interior angle is 120. And so each exterior angle, let's take a real quick look here. It's supposed to be a linear pair. It's got to be 180 total. So this has to be 60 degrees. So 180 minus 120 gives us 60 degrees. The interior angle and the exterior angle will add up to 180. So if you know one of them, you can calculate the other pretty quick. Alright, we have a base of a lamp that is the shape of a nonagon. Well, a nonagon, tried this in a different lesson, and there's no way I'm going to make these all the same. I'm drawing it all over the place. I'm going to bail on that one for a moment. Anyway, a nonagon, how many sides does that have? It has 9 sides. Nonagon is 9. So find the measure of each interior angle. Well, we take our formula for the sum of the interior angles divided by the number of angles, and that's going to equal each interior angle. So we know that we have 9 minus 2 times 180 divided by 9. That's going to give us 7 times 180 divided by 9. We've learned in the past that a nonagon has 1,260 degrees divided by 9, and that's going to come out to be 140 degrees. Okay, calculator would help you with that. So the measure of each interior angle is 140. So if we have 140 degrees, which would be something pretty close to that, then each exterior angle has to add up to 180 with that interior angle. So of course that's going to be 40, because together that's 180. The other way to do it is to take the formula for each exterior angle, 360 divided by n. We know that there are 9 sides, and 360 divided by 9. 9 goes into 36 4 times, and then it's 0 times. Each interior angle of a regular nonagon, just n, each interior angle is 60. Find the number of sides. So they use n-gon because we don't know the number of sides. That's the question. How many sides do we have? So this is supposed to be 60 degrees, which would be approximately like that. Okay? We just don't know how many other sides it has. You may have figured it out already, but we'll just pretend for a moment. Each interior angle of a regular n-gon is 60 degrees. So we're going to take the formula for each interior angle, and we're going to say that that is supposed to equal 60. So we would multiply by n to both sides, and that would cross out, and you'd get n minus 2 times 180 equals 60 n. Sure that looks like a 60 and not an A. Then here we can't divide by the 180 because that's a 60n. They're not like terms. So we're going to come through here and say 180n minus 360 equals 60n. They don't actually have to be like terms, but it wouldn't work out with having n's. This will be a little cleaner. Then we'll subtract the 60n to our like terms, and we'll add our 360 to the other side. So 120n minus, or 180n minus 60n gives us 120n. These cross out and you're left with 360. So as you've already noticed, if the interior angles are 60 apiece, then it's going to have three sides, also known as a triangle. So what we did was take the formula for the sum of the interior angles divided by the number of angles that gives you for each interior angle. Then we multiplied the n to the other side, distributed, and solved for n. We got 3. Each exterior angle of an n-gon, we don't know what number of sides it has, that's what we're trying to figure out, is 30. So the exterior angle, if the exterior angle is 30, that means the interior angle is 150. So it looks like that. And then we keep going around with the number of sides or whatnot. Okay? So one way we could do this is to take the formula for each exterior angle and equal that to 30, because we want each exterior angle to be 30 degrees. Well, we multiply by n to both sides and divide by 30. Three goes into 3 once. 3 goes into, or 30 goes into 36 once. Yeah. So we get 12. We can even try it if we are so doubting ourselves at the moment. We have our 360 and we're dividing that by 30. We came up with 12. So there are 12 sides. So what we call that is a 12-gon. Okay? That'll suffice. Alright, on the flip side, got a couple more questions here. This one is a little interesting. So here we're supposed to figure out the value of y. We're going to solve for the variable. Well, we could either use exterior angles or we could use interior angles, but we need to know something for us to calculate. So we're going to take our values that we know and we're going to figure out our interior angles real quick. Together we know 180. So if that was 180, then this has to be 112 degrees. So 180 minus 68 is 112. And then here, this is going to be a little trickier. Okay? We're going to call this our unknown amount. We'll just pretend for a moment that it is x. So we're going to say that this x plus the y and 48, together they add up to 180. So we're going to subtract the 48 to the other side. And our x value, the amount that's on the inside, we need that by itself. So this crosses out, so we get x equals 132 minus y. So we want to keep it with the y term, not an x term. So we'll come up here and call this 132 minus y. That was probably a little tough. But if we're past that, now it's pretty simple. We have a four-sided shape, so we know that the sum of the interior is 360. So we get 112 plus 2y plus 132 minus y, and then don't forget the right angle is 90. So many people mess that up. Don't skip it. There's no number there, but the box, you know, means 90. And it has four sides, so the sum of the interior is 360. So now we're going to take those and we add our terms together here. We got 112 plus 132 and our 90. That's 334. So 112 plus 132 plus our 90 gives us 334. We have our positive 2y. Be sure that looks like a y. Positive 2y, and our negative y leaves us with a y. So then we're going to subtract the 334 from 360. That gives us 26. So our 26 is here. So 26 plus 48, 26 plus 48 is 74. That's 74 degrees. And 2 times 26, that leaves us at 52. But y is 26. Solve for the variable. The second one, a little bit easier though, because we know what the interior angles are for those. This is 58, so we're going to subtract it from 180 and get 122. So there's our 122. From there, we know that the 87 and the x and the 122 and the 94, that all adds up to 360 because it's a quadrilateral again, four sides. Four sides always, the interior angles of a quadrilateral will always be 360. Alright. So we're going to take this and take our 94 and our 122 and our 87. That comes up to 303. X and 303 is 360. So we subtract our 303 and figure out that x would have to be 57. Alright, last one. We're looking here. We don't know of any parallel lines, so we don't know alternate interior angles or anything. So if this is 112, 180 minus 112, 68. 180 minus 122 is 58. Now again, there's four sides, so the interior angles add up to 360. They're being real nice to us, keeping it to the same amount each time. So the one angle, 2, 3, and 4, all four angles must add up to 360 because that's the sum of the interior angles of a quadrilateral. It's four sides. So we'll take that and say 132 and 58 and 68. That adds up to 258. Take your 360 and subtract that 258. So our X angle has to be 102. Hope you enjoyed.